come to the phone. So up to now, we have done the 1-bit full adder, correct? So now what we'll do, we'll try to make a 1-bit subtraction. 1-bit subtraction. So for that, let us take an example like R is equal to A minus B. This is a subtraction operation, right? Do you feel or not?
Yes, sir.
Very good. Okay. So the next is minus B is a negative number, so we use 2's complement. So how do we represent minus B in 2's complement? So minus B, to convert this into the 2's complement, okay, that is approximately what we do. We do the 1's complement first, right? That we write like minus B. So first B binary will be written. If you recall the 2's complement. So that will become 1 and B binary representation. Binary. Okay. Input B binary representation. So there, after that, what we did, minus is sign bit. So what is the sign bit? Sign bit is set to 1. And the second one is binary is having its magnitude bits, right? Magnitude, sorry. If we any typo mistake, just take it magnitude bits. So then you do the 1's complement plus 1 is equals to 2's complement. Correct? Yep. So then the above equation will become like R is equal to A plus the 1's complement of B. Let me write it as like B plus 1. So now there are 3 bits, like the 1 full adder operation which we did. So in this case, to make the B as 1's complement, so what we do, just drag this B input here. So B will be doing the 1's complement for this. So how we do? Here the C in become, okay, 1, because in 2's complement 1 is added. So for inverting this bit, if you recall the simple AND XOR gate, if giving 2 inputs, for example, 1 bit is the second input, and just let me connect the output. If you recall, if 1 bit is 0, another bit is 1, the result is 1. If input 1 is 1 and input 2 is 0, result is 1. So it is inverting the bits, right? The 2 inputs. The same way, here we can use one more extra and XOR gate to invert the bits. So that is inverting the B bits. So what is there? It is 2's complement. So input 1 is always 1 for inverting the bits. Okay, if B, and then the output of this XOR gate, let me write inverter XOR gate, inverter XOR gate. Let me put it down, leveling, sorry, let me level down it, okay. And the output of this inverted bit will be added with the input, okay. Does that make sense? A plus inverted bit of B. Does that make sense? A plus inverted bit of B. Let me write here, change the orientation up. Let me connect this here. See, if B is 1, its inverted bit is 0. If B is 0, inverted bit is 1. Does that make sense?
Yes, sir.
Good. So A plus inverted bit of B plus 1. 1 is C in. Okay. So this is 1-bit subtraction operation. This is 1-bit subtraction operation. So now you can check it that if A is equal to 1 and B is equal to 0, so 0 inverted bit is 1. So 1 plus 1 is 2, 2 plus 1 is 3. So final carry is 1, sum is 1. If A is 0 and B is 0, so that inverted bit is 1. So 1 plus 0 is 1, plus 1 is 1, that is 2. So that is 1, 0, 1 is carry, sum is 0. Okay. When B is a negative number. So for this performing negative operation, one more extra OR gate is added. So this is 1-bit. To make this as 1-bit adder, simple adder only, C in becomes 0, as you said, the previous doubt. If it is adder means A plus B, it don't require any input, correct?
Correct.
Yes. If the second operand is the negative operand, then C in is set to 1. So this is 1-bit adder.